Alright, so section 7.7. So just like they did back in chapter 3, after we got done with the motion problems, we moved on to mixture problems. So that's what we're going to do again now. So let's go ahead and take a look at some of these. We are on page 313, and it says, mixture problems can also be solved with two variables. Some mixture problems combine items with different values. Using a variation of the following basic equation, you can create a table to organize the information in the problem. So before we were only doing one variable with our mixture problems, and now we're going to go ahead and do two because we're doing the systems of equations. So again, that formula is quantity times cost per item equals total cost. And we're going to get straight into example 1. So, example 1 says, the nut shop sells cashews for $8.15 per pound and almonds for $6.95 per pound. The manager wants to make 80 pounds of a mix of cashews and almonds to sell for $7.25 per pound. How many pounds of each kind of nut should he mix together? So first things first, we need to go ahead and fill in our mixture chart. So we have our cashews, we have our almonds, and we have the mix. Then number of pounds, or our quantity, the price per pound, or our cost per item, and then our total cost. So let's see what our problem told us here. For cashews, we'll call those C. We don't know how many pounds yet. That's what they're asking us. For almonds, we don't know how many pounds of those yet. We'll call that A. And our mixture is going to be a total of 80 pounds. Then our cashews start out at $8.15 per pound. Our almonds start out at $6.95 per pound. And we want our goal for our mixture, our price will be $7.25 per pound. And then our total cost. Well, we know that we're going to have C times 8.15, or $8.15, so we'll have 8.15 C. We'll have our almond pounds that we don't know yet times our price. We'll get 6.95 C. And then for this one, we'll have 80 times 7.25, 80 pounds times our price of $7.25 per pound will give us a total cost of $580 for our mixture in the end. And then we can go ahead and give our two equations. So this, right here, are two costs added together to get our total cost of the mixture. That's our first equation. So our equation for cost is going to be 8.15C plus 6.95A, sorry, I just realized I made that a C up there, that should be an A, equals 580. And then our pounds equation. And our pounds equation will just be the C plus A equals 80, because that's what we know so far. When we can add those two columns down, just like that. So let's go ahead and solve this one together. You can either solve it ahead of time or work along with me. First of all, we want to get rid of these decimals, so we're going to multiply this by 100 because we have two decimal places. So that will turn into 815C plus 695A equals, add our two extra zeros there, so we have 58,000. And then, in the same step, instead of writing everything back out again, we're just going to go ahead and say, well, let's use the elimination method. So how can I get rid of my C's? Well, I'll just multiply this all by a negative 815, so that they'll cancel out. So we'll have negative 815C minus 815a equals a negative 65,200. Now we can use our elimination method. Just add these two lines together. Our c's cancel out. We end up with a negative 120a and a negative 7,200. And then to solve, all we have to do is divide by our negative 120. Make sure you're really paying attention to your negative signs. A lot of these will make sense when they work out, so you'll be able to tell if you missed a negative sign or not. Because obviously we're not going to have a negative amount of pounds of almonds. So we get 60 pounds of almonds. We can just go back to this original equation right here. We said C plus our almonds will equal 80. When we subtract 60, you can probably do this in your head without even having to write it out. We'll find out that C is equals to 20. So we're going to have 60 pounds of almonds and 20 pounds of cashews. So this is goes without saying, I think, pretty self-explanatory, but they do go ahead and go back over solving word problems with two variables. It's very similar to just solving problems with one variable. We should always read the problem carefully, plan by making our table, solve our system of equations that we've obtained from the information in the table, and then always, 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 always check your answer. So, example 2. Emmanuel Christian School sent out 150 pieces of mail. Some required 60 cents postage, while others required 84 cents postage. If the total bill was $108.48, how many pieces of each type were mailed? So, again, if we look back at page 313, you hear me flipping my page, go ahead, flip yours too. Quantity times cost per item equals total cost. So our quantity, our pieces of mail, our cost per item, our price per item, or our price per piece of mail equals our total cost. Just keep that in mind whenever you're building your chart. It's quantity times cost per item equals total cost. So we're going to let X be the number of, let's see, X is the number of pieces of mail at 60 cents, and Y will be the total at 84 cents. And then our total pieces of mail altogether was 150 pieces. Our price per item, we have 60 cents and 84 cents. And then our total cost. So we have 60x because we're just multiplying straight across here. And we have 84y. And they said it was $108.48. We've already multiplied everything by 100 though, because we got rid of our decimal. So we're going to move our decimal place over here as well. So it's going to be 10,848. So they just kind of simplified that. They skipped the step. Instead of writing everything in here with the decimals, they went ahead and multiplied everything by 100 here. So again, we can add up these two columns to get our equations. So the first equation for the pieces of mail, we'll have x plus y equals 150. Then for the cost, we have our 60x plus 84y equals 10,848. And then let's go ahead and solve this one together as well. So for this one, we're going to use substitution. You can use either method you prefer. Actually, I would challenge you to go ahead and pause the video and try maybe even using elimination, see if you get the same answer as me, but let's do substitution for now. So I'm going to go ahead and use this equation and solve for x. So I'll have x equals negative y plus 150. Again, all I did was I just subtracted y from each side so I can solve for x, and then I can substitute that into our equation. So we're going to have 60 times negative y plus 150 plus 84y equals 10,848. Go ahead and distribute. We get negative 60y plus 9,000 plus 84y equals 10,848. Combine our like terms, and we'll go ahead and move this 9,000 over in the same step. So I'm subtracting my 9,000, and I'm combining my like terms. I get 24y equals 1,848. Divide by 24, and I get y equals 77. Then I can just come back to my x plus y. Well, x plus 77 equals 150. I can just subtract 77 from each side, and I get x equals 73. So whenever I go back in there, I can say that I had x, or 73 pieces, mailed at 60 cents a piece, and 77 pieces of mail mailed at 84 cents per piece. Obviously, whenever I checked it out, 73 plus 77 does equal 150. You should also go ahead and sub in 60 times 73 and 84 times 77. Just punch those into your calculator real quick. It only takes a couple extra seconds to make sure that equals 10,848, just to be sure you did get the correct answer. And last but not least, we have the mixture problems that involve combining two mixtures of different strengths in order to get a final mixture of a desired strength. A lot of the ones we did were the different milk fat ones, and that's what we're going to do again here in example 3. Adding pure water is like adding 0% salt solution. Adding pure salt can be thought of as adding 100% salt solution, so those are important things to just remember whenever you're working through these. So for example 3, if milk that is 3% fat is mixed with fat-free milk to produce 5 gallons of 2% milk, how much of each should be used? So we're going to go ahead and let x equal the number of gallons of 3%, y equal the number of gallons of our fat-free milk, and we said we want to have 5 gallons of milk when we are all done with our mixture. Remember, this 2%, that's our mix. Then percent of fat, well, it's 3% milk, so it's going to be 0.03 or 3%. Fat-free, that doesn't have any fat at all, so don't think too hard on it. It's just 0. And then for our final mixture, it's going to be 2% milk. Finally then, we're just going to multiply these straight across. We'll get our 0.03x. Guess what 0 times y is? We're just going to have 0 here, so that makes it really easy on us. And then we have 5 times 2%, or 5 times 200, excuse me, and we get 0.1. Again, for our mixtures, we are adding these columns down to get our equations. So for our gallons, we'll have x plus y equals 5. And for our gallons of fat, we will have the 0.03x. We don't even have to put plus 0. We can, we don't have to. And then that'll just equal our 0.1. Now, what I should have mentioned earlier, remember before we have the price per item, that's going to be substituted out by our percent of fat. So if you want to make a note of that, or just write down the equation again, instead of writing price per item, that's what it was before, price per item. Now it's percent of fat, or percent of whatever we're working with, but that's our percent. All right, so let's go ahead and solve this one. So we have our x plus y equals 5 and 0.03x equals 0.1. First thing we want to do is go ahead and get rid of our decimals. So we'll multiply by 100. We'll end up with 3x equals 10. And then for this one, we actually won't be able to do elimination because we had that 0y, so there's no y to eliminate. So we're just going to use substitution. So we'll solve for x here. And we get x equals 10 over 3. Then we can go back to our original equation, and where the x is, we'll say 10 over 3 plus y equals 5. And then to get the y all by itself, we'll do y equals 5 minus 10 over 3. We end up with y equals 5/3, or y equals 1 2/3. So typically this is where we would go back and solve for x with our y value, but guess what? We already did that. So we already have our x and our y. So x, or the 3% milk, there's going to be 3 1/3 gallons of the 3% milk, and there's going to be 1 2/3 gallons of the fat-free milk. So that's it for this lesson. Again, we're going to stick with the assignment in the book. We're not going to do every single one of these, but we're going to pick and choose some of these mixture problems to work on and not do quite as much on Khan Academy this time. So just let me know if you have any questions along the way.